Writing systems of equations. So far, we have learned how to solve systems of equations. We have the elimination technique, which we learned last class, and we have the substitution technique, which we learned the previous class. And so we're going to actually use both of those when we are talking about questions involving real-world situations. So yes, you can actually see these questions come up in the real world, and I am always going to try to show you that to know that what we're doing actually can be applied to everyday life. So those are our learning targets for today. Now remember, this has been the same statement for the last 3 lessons. It is impossible to solve an equation that has 2 letters, 2 variables. We've been used to, and we've been doing a lot of it, solving equations with 1 letter. So that's our goal, is to get it down to 1 letter. Now in order to do that, I'm going to need to write 2 equations when I have 2 variables, and then use the equations against each other to create 1 equation that has 1 variable. And I'll keep trying to make reference to that, and hopefully that will start to make more sense, because once you understand that concept, a lot of this becomes pretty easy. So question number 1, maybe you've done this before. How many people go to the mall and buy pretzels? I'm not a big pretzel guy. My wife is. She loves going to buy pretzels. I don't know. I just kind of feel like it's a waste. But she likes it, usually does it every time. Anybody else out there buying pretzels every time they go to the mall? Are you the butter pretzel? Are you the cinnamon sugar? The cinnamon raisin? I know they got all sorts of different flavors there. So if you like pretzels, let us know in the chat. That'd be interesting to find out. So Sam goes to this concession stand, maybe Aunt Annie's pretzel stand there, and she buys 3 pretzels, 4 sodas, and pays a total of $11.25. Now Raza goes to the same stand, and that's important because the prices are the same: 5 pretzels, 2 sodas, and a total of $8.25. Now the good news is they tell us what to use for the variables. They use let statements like let P equal the cost of a pretzel and let S equal the cost of a soda. That might not always happen, so you might have to write your own let statements and define your own variables. Now let's write a system of equations that models this situation. Now remember, a system means 2, so that's more than 1. And so my suggestion would be to just start with a couple of equal signs, right? You know they're going to have them. They're equations. So go ahead and get those down. Now, when we read this, underlining, annotating, and rereading it are super important to fully understanding it. Let's first talk about Samantha. Samantha bought 3 pretzels. So we don't know how much they cost. That's what P represents. We do know that she bought 3. So 3 times however much one of those pretzels cost, plus the fact that she bought 4 sodas. Now again, we don't know how much they cost, so we use a variable. We do know the total price was $11.25. So that first equation is all about Sam and how much money she spent on pretzels and soda. And in my mind, way too much. $11.25. Total waste of money, about $11.25 too much. But anyways, that's my personal opinion on that. Raza, she went to the same stand, but she bought more pretzels. She bought 5 pretzels and only bought 2 sodas, and her total was $8.25. So spent a little less, and all of that information is going to help us in order to solve for the pretzels and the soda. First example done. Let's go ahead on to the next one. This one is all about a movie theater. Let me tell you, I am definitely missing the movies. I want them back. I want just movies back, all right? I am missing a good blockbuster, a good action movie that I can see maybe at the theaters or just rent it on DVD or stream it, you know? And right now, they're not even producing those, which is kind of unfortunate. So let's talk movies and think about going to the movies again. The movie theater sells a children's ticket for $4. Whoops, I got my eraser on. And then an adult ticket for $10. And the theater sold 70 tickets for a total of $388. So good information, important to underline, important maybe to annotate, anything you feel is important. Now, let's let C represent the children's tickets. So they're doing our let statements for us. Thank you very much. Question. We do appreciate that. It saves time. We want to write a system of equations. Keys are equations mean equal, system means 2. My suggestion, just get it down, all right? Now, once we have done that, find the totals, okay? So totals, I've got a total of 70 tickets and $388. So 70 tickets and $388. Now I'm labeling these, you don't have to, but the reason why I'm labeling these is it's going to make more sense to write the expression when I know what the total means. So the total money, $388. How did we spend that? Well, let's go back to our question, what we annotated or what we underlined, that is. It was $4 for a kid's ticket, $10 for an adult. So that means it's $4 for every kid's ticket we purchase and $10 for every adult. And notice how the money sticks with the money total. The $4 and the $10 with the number of tickets sold equals $388. Now, in terms of the tickets, we don't have to associate money. All right, tickets are tickets. They don't have any money value. So how can we write this expression? Well, think about what it is, what the tickets are. The tickets are either children's tickets or adult tickets. And there's nothing else. There's no senior citizen. There's no free tickets. They're just children or adults. So that way we can just use C and A. All right. So we've got our two equations down. Now we want to solve this system of equations either using the elimination or substitution method. Elimination method. Okay. So I'm going to come over here and write down the two equations. And this time I'm not going to do any labels so they don't get in the way. So 4C plus 10A equaling 388. Now, in order to create opposites, I'm going to need to multiply. And so I'm going to try to cancel out the C's. So if this is a positive 4 and this is only a 1 and a 1, what am I going to need to multiply by to get opposites? How about a negative 4? Okay, so if you had trouble on the homework last night or on the previous class, this is what we were doing. We were trying to create opposites. So when I do this, I have to multiply everything by negative 4. And that includes the number at the end. So make sure you are basically distributing to all the terms. Now the other equation doesn't need the change. That remains exactly the same because that has what I need. The opposite of 4C, negative 4C. So once I get that far, I can simply just add these two together because currently I have two variables and I need to bring it down to just one. So the C's cancel out. I use normal integer rules, so when the signs are different, I will subtract and get 6A. Going to subtract over here because signs are different. And I'm having a slight senior moment. How about 280? 208, that is, or 108. Whew. That'd be easier if I just thought for a moment. Go ahead, keep solving until you get A by itself, and A is equal to 18 tickets. 6 will go into 108 18 times. So that is the number of adult tickets. Now, we do have to take it back and find the number of children tickets. Much easier to use this top equation here than probably to use the bottom one. So let me see if I can find some space. C plus A equaling 70 tickets. If 18 of those tickets are adults, then I'm going to subtract that from 70 and find out that the number of children's tickets is 52. So 52 children tickets, but they gave us a question, but they didn't give us any variables. So here's a situation where we need to come up with let statements to define variables. Now, kind of obvious here, but let's let H equal the number of hikers and let B equal the number of bikers. And you know, some people want to skip over the let statements. Let me tell you, they're important. They really do help drive the ability to solve the problem. So give yourself those chances to be successful by just doing the little things. Now, all of the people at the park were either hiking or biking, and there were 178 more hikers than bikers, and there were a total of 676 people. So again, I'm going to try to get you into good habits here by just starting with two equations, starting with two equal signs, and then building. One of the things you want to try to look for are totals. 676 total people, right? All together. Now, what type of people were there? There were either people walking, so hiking, or people that were biking, so B. So H plus B. If I write H equals B, that is incorrect. All right, those two things are not the same. They're not equal. We just said there are more hikers. So this is the bigger number. All right, this is bigger than this number. Now, how much bigger? Well, that is actually told to us. 178 more. So if I add 178 to the smaller number, I'm going to represent the number of hikers. Okay? So that actually makes a true statement. Now, how could we go about solving this? Take this expression right here and substitute it into this equation for H. And now I just got to find some room to do that. I've substituted in for H. Then we're going to add the other B and set it equal to 676. And the reason for that is I have an equation with the same variable. And so when the variables are on the same side, I just combine like terms. 1B plus 1B is 2B. 178 plus 178 equaling 667. How about 676? Wow. All right, so let's get my head on straight here and solve this two-step equation by subtracting 178 on both sides. 2b is going to be equal to, how about 498? Last thing to do is to divide by 2, and b is equal to 249. So there were 249 bikers at the park that day. Now, we want to always go back and find both variables, choose which one of these equations you want to use. I'd say this one right here is pretty easy to use because it's already set up for H. We simply have to know the number of bikers and add 178. So take that 249 that we found, add 178. My pen is really sticking, I apologize. 178, and your total number of hikers will be 427. And like I said, there's more hikers than bikers. It's a combination of $10 bills and $20 bills in her purse. If she has twice as many tens and a total of 280, how many of each does she have? All right, Kate, that sounds like a good plan, but we don't have variables. So let's come up with variables. This one's kind of tough because 10 and 20 both start with T. Bills, so maybe just keep it simple and go A. And we know how much a $10 bill is. It's that we don't know the number of $10 bills. Okay, so we're looking for that. And the other one, let's use B for the number of $20 bills. So we've defined our two variables that we plan to use to represent this situation. And like I've been saying, maybe a good idea just to start with equal signs. Okay? Start with equal signs and then look for totals. So one of those totals that should stand out is this 280. So $280. Now, like I've said before, if it's got a money total, that means money's got to go with it. So if I just write A plus B, that's not enough because that's not representing money. That's just how many tens and how many 20s. But we all know that a $10 bill is worth 10 and a $20 bill is worth 20. So that's where I come up with the 10 and the 20. So let's say I had 5 tens. 5 times 10, $50. Let's say I had 5 20s. 20 times 5, $100. Now that clearly doesn't work because my total is 280. Now the other part of this is she has twice as many $10 bills. Many, right? Twice as many tens. So because she has twice as many 10s, she does have more 10s than she does 20s. Now, currently this equation is not true. A does not equal B. The number of 10s does not equal the number of 20s. But if I twice or if I double the smaller number, it will equal the larger number. So for instance, let's